everybody. My name is Mikito Takada. I'm here to talk about on the topic of single-page apps with this title. Let's get started. And I'm not going to start going over, all right, what is a single-page app? I'm just going to assume that you guys know already what that is. It's been out there for quite a while. The technology's been out there. And just start off with the reasons why we write single-page apps. I mean, obviously the first one is just rich interactions, because if we don't have any JS running on the client side, we're not going to actually have access to the events that we would like to have, such as a mouse click down. You can access that. I mean, you could have links without JS, but otherwise it would be impossible. Responsiveness. So the speed of light imposes a certain limitation on latency if you do your rendering on the server. And obviously that's going to be up to hundreds of milliseconds, and that becomes kind of unacceptable even if we could do things without writing single-page applications. Finally, the third reason I think we write single-page applications is reuse. At least hopefully, this has been the promise for a long time, that we can avoid duplicating logic, that we can write we can describe our views once. We can describe our business logic related to views and models once, and then we can just use that both with Node, both on the server and on the client side. At the same time, there are some reasons why we would avoid single-page applications, right? I think the first one is lower productivity. So as I said, that reuse would be one big component. But at the same time, with the current approaches that we're using, it's still kind of more write once on the server and then once again for the client. And that's, well, I'll get into the details a little bit later. Testing is also harder. As Fry says, not sure if app runs perfectly or test framework is failing. When we have single-page applications, often they only run on the client side on the browser. So then you end up using something like Headless WebKit for actually running your tests. And that's just not a seamless way to interact with your test code or with your code, because you're not going to know why is it failing. And you're not going to get that API access that you might want. The time to interactivity is lower. So even though we can respond to user clicks faster by triggering a render on the client side and updating that information, the time it actually takes to load a single-page app is still somewhat of a barrier. You think about Gmail, and you see a loading bar, and you see any other fairly large single-page application, there's always going to be some amount of time involved where you're just waiting for the application to load up its resources, load up its data, and stuff like that. So the time to interactivity kind of suffers. And finally, the pages can't be crawled. So if you curl a single-page app, you'll often just get an empty page, and nothing is going to get rendered. And that's not necessarily a problem if your clients have JavaScript enabled, but many search engines don't. Or if they do, there's really no predictability whether they're going to be able to crawl any of your content. My starting point here for the talk really is current best practice. So you could think of Backbone and jQuery, or you could think of Ember or Angular or any of these other frameworks, which are very good and which solve certain sets of problems. But at the same time, as I mentioned, there were some weaknesses that we currently experience with single-page applications. And in order to actually move forward and try to address some of those issues, we really need to get rid of some things that are considered current best practice, like MVC, namespaces, templating. And I'm just going to present a few brief arguments on that. And then in the second part of my talk, I'm just going to talk more about some of my more recent work, which has been related to solving those issues that I mentioned earlier by doing server-side rendering, by doing snapshotting, by using various techniques. So what's the ideal code base? I've been kind of trying to think about this for quite a while, well, I mean, as somebody said, we've built things that are more complicated than the apps that we're currently building. We've built bridges, and we've built aircraft carriers and things like that. And the difference between these really physical things and the applications that we often build is that the failure modes are independent, and that the different functionality of of real-world things are not usually interrelated. Like if you build an aircraft carrier, if the toilets overflow, you're not going to launch the missiles, because the missile system and the toilet system are two separate systems that are not interconnected in any way. And this is not necessarily true of like a lot of applications where failure modes can be linked and where different modules are quite tightly coupled, so they don't fail independently. And really, this is about complexity, right? And I define complexity just simply as code that has remote inputs or remote effects. The idea being that if you're running a piece of code and then you depend on something that happens somewhere there and you're not really sure what the connection with that somewhere there is, then you're going to have either a remote input or a remote effect. And with like a good code base, ideally, we'd need things to be, it should be possible to load things independently, it should be possible to test things independently, and things should break independently. And this is kind of a prerequisite in some ways to solving some of these problems related to time to interactivity, related to being able to pre-render and package things in a smart way. So that's kind of why I consider some of the so-called best practices perhaps not ideal, or perhaps at least worth re-evaluating a little bit. So what's wrong with MVC? Here in the diagram, well, you'll just see like the basic way we describe MVC, right? So models are the single source of truth. Views observe the model changes. And then we have controllers that receive events from the DOM, render templates, and keep views and models in sync. And all this is kind of uncontroversial, right? So we have MVC, right? We have model, which is data, and view, which is presentation. But what is the controller? Is it something that routes URL fragments to methods? Is it something that coordinates a set of views? Is it something that coordinates a model view pair? Is it something that handles DOM events for one view? I really don't know. The word controller has gotten like way too many different meanings. We're very familiar with the acronym MVC because of all the work that's been done on the server side. But that doesn't really mean that it's productive to actually describe everything as MVC. You can say that a horse is a type of car because you're familiar with horses, or you're familiar with cars and not familiar with horses either way. But that doesn't mean that terminology is necessarily like makes sense in that context. So I mean, this is quite a few responsibilities, right? You receive events from the DOM, you render templates, and you keep views and models in sync. I mean, what does this exactly even mean? Why? I mean, I understand why we want to have MVC. It's because when you say MVC, people are like, oh yeah, MVC. But like, it's not necessarily applicable to the client-side problem. And here's my definition of a controller. It's a familiar word that makes writing glue code sound like a design pattern. So you take controller code, you replace it with the word like glue code, and you'll be pretty good. And the reason for this really is that client side is more like having a lot of models, having a lot of views, and then when you put in the controller, it becomes kind of confusing. You'll have many models and many views interacting on a single page, and they'll be interacting for a long time. And having those controllers between the model and the view, they easily become like magnets for housekeeping code, for glue code. Basically because it's easy to get tempted to, let's add another method that knows about these two models and these two views into the controller. It seems like a good place since, and it's MVC, and we should have all the three different components. But that has a lot of disadvantages because it makes the code harder to separate into different parts. It makes it harder to test because now a lot of your code is in one thing that depends on like a lot of different other things. So you end up having to write like integration tests where you would have been wanting to write unit tests. So I think controllers must die. Like when you have one request and one response, it's fine, because it doesn't really matter what kind of mess you create when you're like writing ad hoc. Like I almost think of it as like writing CGI scripts, like where you just get a request and then you can do whatever, and the main thing is that you return some HTML back. But with single-page apps, we have a persistent state. So we're not just trying to like run a one-off task. We're trying to set up the world in a particular configuration, and then we want to keep interacting with that world through like user events. So we might as well try to replace controllers, move that code away into different places, and try to rather have like generic mechanisms that would solve at least some of these problems. So I mean, you can't avoid having glue code, right? But you can at least move towards the direction where most things are mediated by mechanism rather than mediated by, I will write this case-specific code for this specific set of model, view, and controller. And this is like what I call the modern-day Lego. We have a thing. The thing has a public API, and the thing emits events. And this is like just a basic building block that we can use to build almost anything. And if we start thinking in terms of these reusable things rather than one-off scripts, things get easier. We can put those pieces together, and I'll talk about how in a while. But the general idea being that basically you just have one stage where you connect these two things, and then they interact with each other through events and through their public APIs. And that basically means that the model doesn't have to know about the view. The view knows that it can take one model or X models, but it doesn't need to know what the specific models are. And so when you get like a user event like a click, that becomes an API call on the model. And then that returns an event on the model. That's a change, and that updates one or more views, which then is reflected in the DOM. So we've got APIs and events, and then we've got bindings for those things. And the benefit of this is really that then our code base becomes more separable into different pieces. So we can unit test our views, we can unit test our models separately from each other. And there is no like sanctioned place for code that like collects different dependencies. So you're not going to have like a place where you'll get tempted to add more knowledge about, oh, this specific view and this specific model with these specific names will be connected like this. Instead, you'll have things that will be connected to each other through events and through API calls. Namespaces. Probably if you've ever read anything about JavaScript organization, you have run into the recommendation of using namespaces. Here's somebody saying, it keeps my global scope clean, it enables namespacing, provides a nice way to separate public and private methods and fields. And I say no. The problem with namespaces really is that choices about privacy have to be made on a global basis. So you only have basically two choices. One is, so let's look at this code. So you've got myapp.foo.bar, which is something. It's got a public function called doBar and then a private utility function. And in this case, you're just assigning it to myapp.foo.bar, so the private utility is globally public. Or you can do this one, which is basically you've got a closure, again, wrapping that module, and private util is within that, and now it's globally private. So it's hidden from every other possible user of that piece of code. But what this means basically is that with namespaces, we start exporting things into the global scope because that's the only way we can have this thing here and this thing here reuse the same functionality or reuse the same code. And that creates complexity because now this guy knows the name of this guy and this guy knows the name of this guy. And now most of the code has remote inputs and remote effects. And there really isn't any clear structure, right? So you run into timing conflicts where we didn't load this thing before this thing because it depended on whatever. These kinds of issues. So that's what I see as the problem. And what I really want as a replacement for namespace is something that would actually enforce information hiding. So in OOP terms, we have public and we have private, and we have globally public, globally private, okay? But what I actually want is protected. So I would want something where code that is related to the private util can access that. And by related, I mean it's in the same subsystem, whatever that means for your application. And code that isn't related to it has no access to it at all. And this is, of course, modules. And you may have heard of CommonJS and AMD, but I'll just quickly define what modules are. I mean, modules are basically independent pieces of code that can be loaded. And this is the key part, in order to hide the implementation details behind an interface. And that's the part that people usually miss. Node.js has its own built-in module system. So my approach to this has always been just to write for Node.js and then have like a packaging solution that makes that same code available in the browser. But so what is a module really, basically? Basically, a module is looks something like this, right? You have a thing that is a module. You have some dependencies like jQuery. You're requiring it through a require statement rather than accessing it by through a global namespace or something like that. You have something that's defined there, might be a class, might be a set of functions. And then you have a single export statement that takes that thing and returns it back. So basically, by default, everything within this module is private, except for the thing that you assign to module.exports. So, I mean, it's a convention. It's a convention for saying, oh, these are the things we depend on. And it's a convention for, if we have one thing, that one thing only has one public interface. So isn't this the same thing as a namespace? Well, not even close. First of all, the default is privacy. So you have to explicitly say, oh, this is my public interface. So you don't really accidentally leak things. Things don't have global names. And all of the dependencies go through require. So you can actually have policy that is enforced on the requires. You can impose privacy. And most importantly, modules can be composed into packages. So even if you're familiar with AMD, you might not actually have seen the whole packaging part. So when you're moving from modules to packages, modules without any hierarchy are basically just fancy namespaces, right? I mean, they do impose more structure than namespaces. They do impose the discipline of using a require statement and only having one export. But packages are really where it's at. Packages are like hierarchies of modules. So think if each module is a file, you put them in a directory, you decide that one of those modules is the index for that directory, the thing that determines what gets exported out of that directory. That is a package. So it's a set of modules behind a single public interface. So several modules behind a single interface, but also several modules behind a single HTTP GET. So I mean, a package is just a structure that you could load with a single HTTP GET. And when I'm talking about INDEX.JS, it's basically just another module, this time just a module that exports something out. So it might export the foo, and it might export another function. And everything that's not exported is private. It's only accessible to modules within that same package. And what's a package concretely? So it's something like this. It's a closure, right? It's something that defines a require statement so that you can use that require in your modules. It'll contain the code for several different files. And finally, it'll have like something that assigns something to a global. So window.myPackages modules index.js. The idea being that, so we're taking the exports from the index.js and then putting them on accessible under window.myPackage as a single global. So what should go into that index.js? Well, ideally, very few things. It should be possible to load the package without anything happening. And what I mean by that is that the modules within the package should only define things and not create new state. So if you think about an object definition, right, and then you have an instance of that object, you should only define the objects, but never create instances of those objects. Any code that creates instances of objects or alters the global state should go into an initialization script, which I call init. And init is like the guy who sets up a particular stage. it creates variables, it creates instances of objects within that module. It sets up the module for, sets up the package for use. It might, let's say that the package contains some views and some models. It'll initialize those models, it'll render some views, and then it'll say, oh, view A is related to model B. And then once it's done, it just gets out of the way. It's not involved in any of the interactions after that. It just initializes those views and then gets out of the way. And this means that you could have like a different kind of setup, right? Because the views themselves don't have any global state. So you could set up like different kinds of test scripts that would actually set up a different kind of interaction, like for a unit test or for a different kind of integration test. And the idea here is really that we isolate the side effects or the nasty bits into one place. So everything that creates new variables is in one place. If you need to figure out how does this package work, what happens when I initialize this package, you just read the init function, and you're not going to be surprised by something that creates an instance. Like every time you access something, it creates a new global variable or something like that. Like nothing that should happen. And this makes possible to create unit tests that do different kinds of things. So it's all about information hiding, really. And this is something that a lot of the packaging solutions haven't gotten right. That the most important part really is the information hiding. So packages really exist so that you can hide the implementation details behind a single interface, and you can still share that code within the package. So all I can say is make sure you use a system that actually creates packages and enforces this kind of information hiding. And there's more on this topic on my book as well. Glue.js is a packaging system that I wrote. Just got a simple command line interface. You can just include a set of files. You'll say, oh, I want the output to be this file name. I want the global to be called my package. And then if you do require jQuery, I want that to return window.$. And it creates a package out of these different modules, and then make sure that that the output gets exported under this global my package. And it's based around basically just like having normal common JS node-based modules. Packaging here really isn't about performance, it's about maintainability. So it's really important. It's not something that you can just say, oh, well, we won't do any packaging because, well, we don't care about the performance right now. It's more, again, about hiding the internals. And there are other options. You can use AMD, which there's probably been a talk at this conference about. And definitely there's info online as well. I think it's mostly a bike shedding debate. The real thing is really just organize your code using modules and packages. So templating was one of our good ideas. Instead of rendering things on the server, we'll have a set of templates that when you give them some data, they turn into a string of HTML. And then later on, we'll manipulate that HTML through the DOM or jQuery. And I mean, this is the basic recommendation I think Backbone gives you, right? They have a very minimal view that doesn't really say anything about what a view layer should do. They've got good models. But, and so this is where you end up often. You'll just write some templates that manipulate HTML, and then you have a controller that does like a one-off task that, that manipulates that HTML in some way. And so you think about a web page or a single-page app as a series of string processing tasks. But the problem with templates really is that you can't really nest them. And there's a lot of manual work involved in rendering them, in passing data to them, in actually binding DOM events and making them interactive. So I think declarative views and bindings are actually the way to go, and I'll talk about those a little bit more later on. So here's the state of the art, and I'm hoping I didn't go too fast. You have entangled controllers, so you rely on controllers that coordinate very many different things, that run these one-off kind of tasks, which leads to kind of having big integration tests. You end up using namespaces where you don't hide information like the implementation details of views or models. So the code is hard to split into small pieces, hard to unit test separately. and it's hard to load independently. You have templating that requires a lot of housekeeping, so the views can't be rendered on the server, or if they can, it's a one-off process. Again, it's setting up some templates, it's setting up some namespace, it's setting up some controllers, and it becomes kind of quite tedious. So, having covered some of that base stuff, basically, controllers must die. Namespaces, replace them with packages. And templates are like, force you to write too much housekeeping code. I'm just going to have a look at like where I think we're going to be going, hopefully, towards a brave new world where we'll be maybe applying these constructs differently, and trying to solve, again, some of these basic problems. So again, I started off with the reasons to avoid single-page applications, right? The ones I listed were lower productivity, testing is harder, time to interactivity is worse, and the pages can't be crawled. And I think there's like a benchmark for all of these. For lower productivity, basically, I would be a happy man if writing a single-page application would be as simple as writing an HTML page, a basic HTML page. When it comes to testing, I'd be very happy if I could use Mocha or just like run simple tests from the command line, have them complete fast, not have to worry about like running a headless WebKit or some other browser emulator. In terms of interactivity, basically a static page is the best we can do, right? It's something that we've written the HTML in advance. There's no JavaScript running. The page just returns, and you can immediately see the results of that page. And then in terms of crawlability, well, that's actually related to the whole static page thing where static pages work with curl, but single-page applications don't. View.json is basically a view layer. It's very alpha quality. It's not public yet, that I've been working on. It works with Backbone. It works with something called unbundled model, which is just an alternative model layer I've been playing around with. The rest of the talk is really about the ideas behind it, which you should steal as much as the library itself that's not quite yet public. It uses a bunch of already public modules that I've written for support, including Glue.js and some other things. So what are the problems that I'm trying to look at here when I'm thinking about how are we going to do rendering for single-page applications, hopefully in the future? One is productivity, basically just trying to get to that HTML benchmark, or that benchmark of the ease of writing an HTML page. Cross-environment rendering or testing. So I would like to be able to run my views in Node and just have them return that markup that I wrote before. I would like to be able to test them in any environment, so I wouldn't need to run a browser separately. And I would like to have instant interactivity. So I would like the page to load as quickly as it can, and I would prefer if that page would also be crawlable by search engines. In other words, that it would actually show something useful even without JavaScript turned on. Not necessarily work perfectly, but well enough for a search engine. Now there's a lot of components here to cover, and I can only give you like a brief overview of these different kinds of things. But I covered these kind of things on the left earlier. There's an init script, there's a model, there's a view. You've structured your code so that these things are reusable. And then there's a set of mechanisms that lives around that actually makes it possible for us to have fast render times, to have a fairly productive environment to work in. And these I'll talk about individually. So productivity, again, it should feel as productive as HTML. The approach that Vue.json has taken is the one that many other frameworks have taken, which is basically uses declarative views and bindings. A declarative view is basically you say what the computation that should be done is and not how to compute it. In other words, you say, oh, I've got this piece of HTML. I want it to show this model. And that's it. You don't tell it how you will show it. You just say, all right, I want this piece of information to be shown here. Instead of the way in which you'd do it if you'd write it with jQuery, which would be, when X is added, create an element, assign value, blah, blah, blah. Like you tell it all the steps. And that's just because, like, in most cases, we can just kind of use a few fairly simple patterns to show information. And we don't really need to be writing all this housekeeping code. So the idea here is basically that you'll say specify binding between the data and the HTML using some sort of name. So you'll have a view, right? The view will refer to a model by name. There's going to be a name resolution bit that takes that specific model, and then it creates an event registration on that. So the thing on the left basically happens when you instantiate a specific view. And then the model data changes. Well, the model runs, triggers that event and runs the registered code, and then the view gets updated. It's quite simple, but by reducing the interactions between the view and the model to this, it becomes a lot easier to actually do rendering on the server side as well as on the client side. Here's an example of a declarative view, right? There isn't really like that much to it. The idea being, you bind some name. Here it's to-dos. It's a collection, and you want the title of that of the models within the to-dos collection to be shown. And that'll render like a list with the items that you want it to have there. So you don't really have to go into the details of, oh, okay, well, if a to-do is removed, if a to-do is added, what are you going to do? It'll just update itself so that it reflects the content of the collection. And again, this is not really cutting-edge stuff, right? It's something that has already existed in other view rendering or view layers. It's just that being able to do this on the node side. And there are like 3 kinds of declarative views that you can reduce things to. So one is, I have this thing that reflects this data. So I just need to render, the name, the title, whatever. And then I have this group of things, and I want to show that collection in this place. So you'll have a collection view. And then the third one is, you have an if statement, basically. You have a piece of logic, and you want to show different things based on the result of that expression. And so a lot of problems really reduce down to these, which is kind of obvious since it's like a variable, a for loop, and a if statement, right? And that's what we use to program. So, so declarative views can definitely go pretty far in representing like the different kinds of things that we want to show in single-page applications. Vue.json does some things differently, so it's fairly node-oriented, or it's fairly JavaScript-oriented, really. You can just take something like a template and compile that down, and the result of that is not actually a function, but an actual object, or an actual object prototype definition that is instantiable. So what you get as the result is basically an object that you can say, all right, new view. And it's got a render method, and it's got a few other helper methods, but beyond that, it's just a normal object, like an normal ES3 prototype object, rather than like somebody's interpretation of what class inheritance should be. And you can run it inside Node, so you could actually just instantiate it and then console log it, and it'll run in either the server or on the client. And the general idea being, you have some markup, you've got a view compiler. The name view.json really comes from the idea that all the views compile down to JSON, which is like used as an intermediate representation. And then that JSON compiles to actual JS objects. This is basically mostly so that if you want to like add new things to your view markup or declarative views, like new expressions or internationalization or things like that, you have a place where you can do that. So we want to do cross-environment rendering. It should be easy to test the code, and it should be easy to render a view as a static page. So, and the same code should run everywhere. So the way I've approached this is basically to reduce DOM manipulation directly, and instead use these declarative views that have like fairly well-defined interactions, and then use shims that change the rendering environment and allow you to run the same code in different environments. So the code that you write stays the same, but the code surrounding it changes. And what is a shim? A shim is just a small library that transparently intercepts an API and handles calls appropriately. So in the case of view.json, you have like a jQuery shim, a not old IE shim, which is basically a jQuery-less, framework-less view that basically just uses like some of the newer APIs that are not available on old IEs, and then translates those into DOM operations. You've got a node shim that allows you to run those same views on the node side, and a debug shim just to get an idea of, all right, what is happening, how long is this taking, and so on. And so the rendering basically just proceeds from getting an event that's intercepted by a view. The view has a certain API that calls the shim functions, and the shim functions translate that to an HTML update on the server or on the client side. And just by swapping the shim, you can just get, we can render the same view in different environments, whether it is in the browser or on the server. Finally, like this instant interactivity. So we should be as fast as loading a static page. Again, it can't change the speed of light, but we can think of two questions. The first being, what is the least that we can load? And the second being, what's the least processing that we can run? This is where the packages stuff that I talked about earlier comes kind of handy. Because once your application is structured like that, you can basically say, oh, OK, I have this core, and then I have my current activity. I have my current view that that the user wants to see based on the URL that we're getting. And then you can say, oh, OK, well, the core will probably contain like jQuery and maybe your model definitions. And then the package for that specific thing that the user is viewing will probably contain like a set of views, maybe some model data and some stuff like that. But you can load a very minimal amount of the code, because you can just say, oh, OK, well, as long as I have the core and I have the package that I need for this functionality, that's all that's really needed. So you reduce the loading times from having to load like a full application to, OK, I have got this neat partition where I can just load this part, and then if I need to load like additional functionality, I can do that in the background later on. But from a user perspective, the experience is better because there's not just that much data that gets transferred. The other part is state snapshotting, which is, again, something that's provided by the framework, something that's available as a separate module as well. The idea being basically that you can run some of the processing, you can render the views, or you can fetch model data, you can serialize that model data, and then have the results continue running on the client side. And then pre-processing or pre-rendering, again, currently a lot of the frameworks ship a templating compiler to the end user. They might support pre-compilation, but then still there's a lot of housekeeping involved. A lot of the load time that a single page application is spending during the initial load is really not just like loading the framework, but also realizing, oh, this model depends on this thing, so I have to fetch more and more data from the back end before I can actually render anything. So by pre-rendering and by using state snapshots, you can just send that data directly, and you'll be confident that you can do the initial render, or that you have the base set of data that you need. So with snapshots, you can start running the code on the server and then say, oh, OK, well, I'm going to send this as a snapshot, and then continue running that on the browser. And with pre-rendering, you'll just sort out the HTML part, where you take that view, you render it as an HTML page, and the result already works even if you don't have JavaScript running, or even if you are a search engine that's crawling those pages, you'll still get that HTML. And then the time to initial render, initial interactivity becomes a lot more predictable. So again, an init function that sets up models and views. This happens on the server side. The models get, or the model data and the models themselves get put into a snapshot, and then they get, on the client side, they become just JS variables. And the view, you use a shim, you render it as HTML, you send that HTML with the initial page load. So it looks something like this, right? So you'll have like a core that's jQuery and framework and whatever. You'll have the current package that defines, the views that you're using here. And then you'll have the snapshot of that data or of the code that you were running on the server side. And then you'll have the current HTML that you rendered on the server side, meaning that the initial render time goes down quite a bit. Now, when I say pre-rendering, it's not just like, oh, we've got a template and we'll render that thing. It's also just like a full emulation for those view interactions. So you can actually interact with the HTML elements. You can add new things to models, and all that gets reflected in the HTML. So it's not just like sending a precompiled template. It's sending a real HTML, and then the view state associated with that HTML. So you can really continue executing from where the server left off. And snapshotting, I'm not talking just about JSON, rather like a more comprehensive serialization where, if you create a data object, you get a data object back. You create a regular expression, you get a regular expression back. You have models and collections. You don't get like JSON that represents those, but you actually get instances of those models and collections on the client side. And you can have references to different objects, and those will be stored as references. So if you've assigned an object as a property, you'll get that property back. So it's kind of like a more comprehensive way of serializing this kind of data, which allows for this seamless, oh, okay, server left off here, client continues here. So I've looked at all these different parts a little bit, but I don't really have enough time to actually go into like a lot of depth. But, so how big is this thing? How bad is it? The view layer is 400 lines of code, which is kind of surprising, but it is really possible to implement a lot of this functionality using a smaller set of, or smaller amount of code. And that's been something that's been like a design objective for me, to keep the runtime for the single page app framework fairly small. And also to avoid trying to reinvent things. So, almost I guess pretty much every single page app framework today comes up with their own, this is my own class system. Which I think is a problem, because then you get no interoperability. So I've been trying to just avoid reinventing things that do exist, things like the inheritance systems, because it really doesn't matter. I have my own model layer, yes, but that is fully event compatible, API compatible with Backbone. And then the compiler that creates these views is larger, but it's only used during the pre-compilation stage, so it never gets shipped to the browser, and it never runs there. So in terms of like an app developer's perspective, you're only dealing with this view layer code, which is a few hundred lines of code, which should be fairly nice. So in summary, the direction I think, or I hope, or I speculate, I mean, predictions about the future are usually wrong. Where we're going is we're going to be going more towards treating views as objects rather than treating them as strings or templates, because that just reduces the overhead of like connecting templates to view objects to whatever. Moving slightly away, at least, from this CGI-inspired idea of like one-off scripts, one-off controllers, towards having just event registrations and public APIs. Moving away from being only able to run your framework on the client side to being able to render your views and your application anywhere. So anywhere where you have the capability to execute JavaScript, you will be able to render your views. Which basically means that multiple page applications become like a special case of single page applications where, oh, well, we'll do all the renders on the server side. Instead of having frameworks that really require DOM in order to work, you move towards frameworks where the DOM is abstracted out. You interact with it through a shim or a limited set of things, and this is so that you can render anywhere. And then we'll just move towards better serialization, better loading, so that, again, we reduce that time to interactivity with single-page apps. And we can have them behave more like normal web pages that load quickly, rather than like feeling like, oh, OK, I've been waiting here for 10 seconds for this thing to start up. Some links. So single-page app book. It's less about all this future-y stuff. It's more about what currently exists. It's got some half-decent chapters on like modularity and packaging, which I feel like is one of the big points. View.json, I've got, so I'm iterating on the documentation right now. It's kind of, the hard parts are technically are kind of solved, but the part that really I am most concerned with is how does it feel to actually use the framework. Right now, there's just not enough defaults. The API is a little bit too verbose and things like that. So I'm really just trying to get the experience right before releasing it. Also recommended is ZenDesk.com, which is a new real-time framework that I wrote a while back that we're now open sourcing. Or my employer, ZenDesk, is open sourcing. But thank you.